Imagine waking up one morning to find that every clock in your house has stopped. Your wristwatch sits frozen, your phone displays a blank screen where the time should be, and even the old grandfather clock in the hallway has fallen silent. You might think this is simply a power outage or some strange technical glitch, but what if I told you that something far more profound might be at work? What if time itself, that invisible river we all seem to float upon, doesn't actually exist at all? Welcome to a question that has puzzled philosophers, tormented physicists, and kept curious minds awake for centuries. Tonight, we're embarking on a gentle journey through one of the most fundamental mysteries of existence. Does time truly exist, or is it perhaps the most elaborate illusion ever woven into the fabric of reality? Before we drift into this cosmic puzzle, I'd love to know where in the world you're experiencing this moment. Are you settling into bed as evening light fades through your window, or perhaps listening as dawn breaks quietly in your corner of the globe? Whatever time it shows on your clock right now, hold that thought, because by the end of our exploration tonight, you might find yourself questioning whether that number has any meaning at all. If you find comfort in these sleepy scientific wanderings, I'd be ever so grateful if you gave this video a gentle like and perhaps subscribed. It helps other curious souls find their way to this quiet corner of wonder. And I do hope this investigation isn't so fascinating that it keeps you awake. Though if it does, at least you'll drift off with some rather extraordinary ideas about the nature of existence itself. So settle in, let your thoughts slow to a peaceful rhythm, and let's begin to unravel the mystery of time. Because somewhere between the ticking of clocks and the turning of pages, between memory and anticipation, between the flutter of your eyelids and the beating of your heart, lies one of the most beautiful and bewildering questions we can ask about our universe. Time has always felt like the most reliable companion we have. It wakes us in the morning, guides us through our days, and tucks us into bed each night. We measure our lives by it, plan our futures around it, and treasure our memories within it. But what if this faithful friend is actually a masterful magician, creating the grandest illusion of all? The question of whether time exists isn't just philosophical poetry, though it certainly sounds like it. It's a serious inquiry that sits at the heart of modern physics, one that has led some of our brightest minds to conclude that time, as we experience it, might be nothing more than a persistent and convincing dream. Let's begin with how time feels to you right now. As you listen to these words, you're probably aware of a gentle forward motion, a sense that moments are flowing from past to present to future, like a quiet stream. This feels so natural, so obvious that questioning it seems almost absurd. But that feeling, that sensation of temporal flow, is precisely what scientists have begun to doubt. Think about your day to day. You might remember having breakfast this morning. That was your past. You're listening to this now. That's your present. And you might be planning what to do tomorrow. That's your future. This division seems clear and absolute. The past is gone, the present is happening, and the future is yet to come. But according to some interpretations of modern physics, all three breakfast, this moment, and tomorrow's plans exist equally. They're all simply different locations in the landscape of space-time, no more separated than different rooms in the same house. This idea, called eternalism or the block universe theory, suggests that time doesn't flow at all. Instead, all moments past, present, and future exist simultaneously in what physicists call a four-dimensional block. Your birth, your first day of school, this very moment of listening, and even your eventual old age are all equally real, all equally present, just located at different coordinates in space-time. It's a bit like looking at a film strip. When you watch a movie, you experience it as a flowing sequence of events, but the entire film exists all at once on the reel. Every scene, from opening credits to final frame, is there simultaneously. The movie doesn't flow, you simply experience different parts of it in sequence. According to eternalism, time might work the same way. But if that's true, why does time feel like it flows? Why do we experience this persistent sense of moving from past to future? The answer might lie not in physics, but in psychology. Our brains might be constructing the sensation of temporal flow from something that is fundamentally static. Consider how memory works. You can recall the past, but you cannot remember the future. This asymmetry creates a psychological arrow of time, a sense of direction that makes it feel as though time is moving forward. But this might be more about how consciousness processes information than about the true nature of time itself. Some physicists go even further. They suggest that time is what's called an emergent property, something that arises from more fundamental processes but isn't basic to reality itself. Just as the concept of temperature emerges from the motion of countless molecules, time might emerge from the interactions of more basic elements of the universe. These nows don't change or evolve, they simply exist. Our experience of time passing is really our consciousness threading together these static moments, like beads on an invisible string. In this view, time isn't something that exists independently. It's not a river we float upon, or a stage we perform upon. Instead, time is more like a story we tell ourselves, a narrative we construct to make sense of the relationships between different configurations of matter and energy. This isn't just abstract theorizing. Some of the most successful theories in physics, particularly when we try to describe the universe at its most fundamental level, seem to work better without time as a basic ingredient. When physicists attempt to write down the equations that govern the entire universe, time often disappears from the mathematics entirely. But here's what's truly remarkable about this puzzle. Even if time doesn't exist in the way we think it does, our experience of temporal flow remains one of the most profound and meaningful aspects of being human. Whether time is real or illusory, we still live within its apparent structure. We still cherish memories, savor present moments, and dream of future possibilities. Perhaps the question isn't whether time exists, but rather what it means for something to exist at all. If time is an illusion, it's an illusion that shapes every aspect of our lives. It's an illusion that allows us to have experiences, to learn, to love, to grow. It's an illusion that makes consciousness possible. And maybe that's enough. Maybe the reality of time isn't about whether it exists independently of our minds, but about how it enables the rich, complex, beautiful experience of being alive. Whether time is fundamental or emergent, real or constructed, it remains the invisible thread that weaves together the tapestry of existence. As you settle deeper into this moment, whatever moment this is in the grand scheme of things, perhaps you can appreciate the mystery we live within. Every second that seems to pass, every heartbeat that marks the rhythm of your life, every breath that carries you from one now to the next, you're participating in one of the deepest puzzles the universe has to offer. Time might be an illusion, but if so, it's the most beautiful illusion we know. It's the illusion that makes stories possible, that gives meaning to change, that allows for the gentle progression from question to wonder to peace that we're sharing right now. So as you drift towards sleep tonight, carrying with you these strange and wonderful ideas about the nature of time, remember that whether time is real or imagined, this moment exists. Your thoughts exist. Your quiet contemplation of these mysteries exists. And in the end, perhaps that's the most profound truth of all. Rest well, fellow traveller, through the mystery of time. Now we arrive at the heart of the mystery, the question that has quietly followed us through Newton's clockwork cosmos and Einstein's fluid space-time. If time can bend and stretch, if it depends on motion and gravity, if it might even emerge from more fundamental processes, then what does this tell us about the nature of existence itself? Are we living in a universe where time is as real as the stars and planets, or are we dancing through an elaborate illusion, a cosmic sleight of hand where moments only seem to flow? This question isn't just academic. It reaches into the core of what it means to be human, to remember, to hope, to feel the gentle passage of seconds as you listen to these words. Because if time doesn't exist in the way we think it does, then what are we to make of our lives, our stories, our sense that we're moving from somewhere towards somewhere else? Let's begin with what we've learned so far. Physics has shown us that time is far stranger than our everyday experience suggests. In Newton's universe, time was absolute, universal, ticking along at the same rate everywhere. But Einstein revealed that time is relative, personal, dependent on how fast you're moving and how close you are to massive objects. At the quantum level, time becomes even more puzzling, sometimes disappearing entirely from the equations that describe reality. And yet, despite all this strangeness, time continues to feel utterly real. You woke up this morning, you're listening to this now, and eventually you'll drift off to sleep. Your memories stretch behind you like a path through a forest, and your future lies ahead, uncertain but approaching. How can something that feels so fundamental, so woven into the fabric of experience, be anything other than real? One possibility is that time is emergent, arising from deeper, more fundamental processes. Think of it like temperature. When you touch a hot stove, the heat feels immediate and real, but temperature is actually just the average motion of countless molecules. No single molecule has a temperature, but when you gather enough of them together, the property emerges. Perhaps time works similarly. At the deepest level, the universe might be timeless, but when you zoom out to our human scale, time emerges as a useful way to describe how things change. This idea gains support from some interpretations of quantum mechanics. In the Wheeler-DeWitt equation, which attempts to describe the quantum state of the entire universe, time doesn't appear as a variable. It's as if the universe, at its most fundamental level, simply exists in a vast eternal now. All moments, past, present, and future, might be equally real, like pages in a book that exists all at once. But if that's true, why do we experience time as flowing? Why does it feel like we're moving through moments rather than existing in all of them simultaneously? One answer lies in the nature of consciousness itself. Our brains are memory-making machines, constantly creating records of experience. When you remember yesterday or anticipate tomorrow, you're not actually traveling through time. You're accessing patterns stored in your neural networks. The experience of time's flow might be a story your brain tells itself, a narrative constructed from the sequence of memories and the anticipation of future events. In this view, the present moment isn't a moving point on a timeline. It's simply the state of your consciousness right now, accessing particular memories and constructing particular expectations. This connects to something philosophers call the psychological arrow of time. We remember the past but not the future, and this asymmetry gives us a sense of direction, a feeling that time has a flow. But this might be more about the nature of memory and consciousness than about time itself. After all, if all moments exist equally, then the flow of time isn't a property of the universe. It's a property of minds like ours, evolved to navigate change and make sense of cause and effect. Consider this thought experiment. Imagine you could step outside of time, like a reader flipping through the pages of a book. From this perspective, you might see your entire life laid out like a landscape, every moment equally present. Your first steps, your first heartbreak, this conversation we're having right now, all existing simultaneously in what physicists call the block universe. The experience of moving through time would be like reading the book page by page, but the whole story would already be there, complete and unchanging. This view, called eternalism, suggests that becoming is an illusion. Nothing ever truly happens, nothing ever truly changes. Instead, everything simply is, spread out across the dimensions of space-time like a vast, four-dimensional sculpture. Your past self isn't gone. It's just located at a different point in space-time, as real as your present self, but existing at a different temporal coordinate. It's a beautiful and deeply strange idea, but it raises profound questions about free will, responsibility, and the meaning of choice. If your future already exists, laid out in the block universe, then are you really choosing what to have for breakfast tomorrow? Or are you simply discovering what was always going to happen? If all moments are equally real, then what does it mean to say that something matters, that decisions have consequences, that we can shape the future? Perhaps the answer is that these questions miss the point. Even if time is an illusion, even if all moments exist simultaneously in some vast eternal now, we still experience life as a sequence of moments. We still feel joy and sorrow, still make choices, and live with their consequences. The illusion, if it is one, is so complete, so perfectly integrated into the fabric of consciousness, that it becomes indistinguishable from reality. Think of it this way. When you watch a movie, you know it's just a series of still images flashed in sequence, but you still experience it as motion, as story, as meaning. The illusion doesn't diminish the experience, it creates it. Perhaps time works similarly. Whether it's fundamental or emergent, real or illusory, it remains the medium through which we experience existence. And maybe that's enough. Maybe the question isn't whether time exists, but how it shapes our experience of being alive. Time gives structure to our stories, rhythm to our days, meaning to our choices. It allows for memory and anticipation, for growth and change, for the possibility that tomorrow might be different from today. There's something deeply comforting in this perspective. Even if time is ultimately an illusion, it's an illusion that makes love possible, that allows for hope and healing, that gives weight to kindness and meaning to effort. It's the illusion that lets us say goodbye and hello, that makes reunions sweet and partings poignant. So as we drift toward the end of our exploration, perhaps the most profound truth about time isn't whether it exists, but how it enables existence to feel meaningful. Whether time is fundamental or emergent, absolute or relative, real or constructed, it remains the stage upon which the drama of consciousness unfolds. And on that stage, every moment matters, every choice resonates, every story finds its meaning in the gentle, mysterious passage of what we call time. Looking at the quantum mechanical interpretation of time, we find ourselves in a realm where the familiar clockwork universe of Newton begins to dissolve into something far more mysterious and profound. While classical physics treats time as a steady river flowing from past to future, quantum mechanics whispers that perhaps time itself is more like a jazz improvisation, fluid and uncertain, where the very act of observation shapes the melody. The fundamental equations of quantum mechanics reveal something extraordinary about time's nature. In the Schrödinger equation, which governs how quantum systems evolve, time appears as what physicists call a parameter, not a dynamic variable. It's like the conductor's baton in an orchestra, keeping the rhythm but never itself becoming part of the music. This creates a peculiar asymmetry in our understanding. While position, momentum, and energy can all exist in quantum superposition, hovering between multiple states simultaneously, time marches forward with classical certainty. But this apparent simplicity masks deeper mysteries. When we peer into the quantum world, we discover that particles don't have definite positions or velocities until we measure them. They exist as probability clouds, mathematical descriptions of where they might be and what they might be doing. Yet somehow, these ghostly probability waves evolve according to precise temporal rules. It's as if time provides the stage upon which quantum uncertainty performs its strange dance. The relationship between quantum mechanics and time becomes even more intriguing when we consider the measurement problem. In the quantum realm, the act of measurement seems to collapse the wave function, forcing a particle to choose a definite state from its cloud of possibilities. But when exactly does this collapse occur? The quantum equations themselves are perfectly reversible, meaning they work just as well backward as forward. There's nothing in the mathematics that gives time a preferred direction. This reversibility creates what physicists call the quantum arrow of time paradox. While the microscopic world of quantum mechanics appears time-symmetric, the macroscopic world we inhabit clearly has a temporal direction. Eggs break but don't spontaneously reassemble, coffee cools but doesn't reheat itself, and we remember the past but not the future. How does this directional arrow emerge from fundamentally reversible quantum processes? One of the most compelling answers lies in the phenomenon of quantum decoherence. When a quantum system interacts with its environment, and in practice every system eventually does, the delicate quantum superpositions begin to break down. The system becomes entangled with countless environmental particles, and this entanglement effectively destroys the quantum coherence that allows for superposition states. The result is the emergence of classical behavior from quantum foundations. Decoherence doesn't just explain how quantum systems become classical, it also provides a natural explanation for time's arrow. The process of decoherence tends to increase the total amount of quantum entanglement in a system, and this increase appears to be irreversible. In essence, the universe's quantum information becomes increasingly scrambled over time, creating a temporal direction that points from less entangled states toward more entangled ones. This connection between time and quantum entanglement has led to some of the most fascinating theories in modern physics. Some researchers propose that time itself might be an emergent property of quantum entanglement. In this view, what we experience as the flow of time is actually the universe's way of organizing and processing quantum information. The more entangled the quantum state of the universe becomes, the more time appears to have passed. There's also the intriguing possibility that quantum mechanics might allow for a kind of temporal non-locality. Just as quantum entanglement creates mysterious correlations across space, some interpretations of quantum mechanics suggest that correlations might exist across time as well. Future measurements might, in some sense, influence past states, creating a web of temporal connections that challenges our linear understanding of causality. The many worlds interpretation of quantum mechanics offers perhaps the most radical reimagining of time's nature. In this view, every quantum measurement doesn't collapse the wave function, but instead causes the universe to split into multiple branches, each corresponding to a different measurement outcome. Time becomes not a single river, but an ever-branching delta, with countless parallel timelines flowing simultaneously through the multiverse. If the many worlds interpretation is correct, then the time we experience is just one thread in an infinite tapestry of possibilities. Every decision, every quantum event, every moment of uncertainty spawns new branches of reality. Our personal timeline is simply the path we happen to be following through this vast garden of forking possibilities. This branching view of time has profound implications for how we understand causality and free will. If every possible outcome of every quantum event actually occurs in some branch of the multiverse, then perhaps our sense of making choices is really just our consciousness following one particular path through the quantum maze. The roads not taken aren't lost. They're simply experienced by other versions of ourselves in parallel realities. Recent developments in quantum gravity, the attempt to merge quantum mechanics with Einstein's general relativity, have pushed these ideas even further. Some theories suggest that, at the smallest scales of space and time, the familiar smooth flow of temporal experience breaks down entirely. Time might become granular, composed of discrete units smaller than anything we can currently measure, or it might become probabilistic, with the very sequence of events becoming uncertain until observed. The Wheeler-DeWitt equation, which attempts to describe the quantum state of the entire universe, reveals something even more startling. When applied to the cosmos as a whole, time disappears entirely from the equation. The universe, from this perspective, exists in a timeless quantum superposition of all possible states. What we experience as temporal flow might be nothing more than the way conscious observers navigate through this static quantum landscape. This timeless view of quantum reality suggests that our experience of time might be fundamentally subjective, a product of how consciousness interacts with the quantum substrate of reality. Different observers with different ways of processing quantum information might experience time differently. The flow of time might not be a universal feature of the cosmos, but rather a particular way that minds like ours make sense of the underlying quantum structure. Yet for all these theoretical possibilities, the practical implications of quantum mechanics for our daily experience of time remain subtle. The quantum effects that might influence temporal perception operate at scales far smaller than our conscious awareness. We live in what physicists call the classical limit, where quantum uncertainties average out into predictable behaviors. Our clocks tick steadily, our appointments arrive on schedule, and our memories form in orderly sequence. But perhaps that's the most beautiful aspect of quantum time. While the deepest levels of reality might be fundamentally uncertain, probabilistic, and strange, they give rise to the stable, predictable temporal experience that allows consciousness to flourish. The quantum world provides the foundation for classical time, just as the quantum dance of particles provides the foundation for the solid matter we touch and the thoughts we think. As we drift towards sleep, we might imagine ourselves as quantum observers, navigating through the probability waves of the universe. Each moment of consciousness is like a measurement, collapsing the infinite possibilities of the quantum future into the single, definite experience of the present. And perhaps in the liminal space between waking and sleeping, we can almost sense the other possibilities, the other paths through time that exist somewhere in the vast quantum multiverse, waiting to be explored by other versions of ourselves in other branches of reality. The quantum nature of time reminds us that even our most fundamental experiences, the very flow of moments that defines our existence, might be far stranger and more wonderful than we imagine. In the end, whether time is classical or quantum, deterministic or probabilistic, singular or multiple, it remains the medium through which consciousness experiences the universe. Now we arrive at one of the most profound questions in all of physics, one that might sound simple at first, but leads us into the deepest mysteries of existence itself. If time emerges from quantum processes, if it's woven into the fabric of space-time, if it shapes every moment of our lives, then what happens to time at the very edge of understanding? What occurs when we peer into the heart of a black hole, where gravity becomes so intense that even light cannot escape? Black holes are perhaps the most extreme laboratories in the universe, places where our understanding of time doesn't just bend or stretch, but reaches its absolute limits. They're cosmic monsters, with gravitational fields so powerful that they warp spacetime into impossible shapes, creating regions where time itself behaves in ways that challenge everything we think we know about temporal flow. Let's begin with something Einstein predicted, but never quite believed could exist. In his equations of general relativity, there appeared solutions that described objects so dense, so gravitationally intense, that they would create what physicists call an event horizon. This is not a physical boundary you could touch or see, but rather a point of no return in space-time itself. Cross this invisible line, and you can never come back. Not because you lack fuel or thrust, but because the very geometry of space and time conspires against your return. At the event horizon of a black hole, time doesn't just slow down, it approaches a kind of temporal standstill. This is gravitational time dilation, taken to its most extreme conclusion. If you could somehow hover just outside the event horizon and watch a clock falling toward the black hole, you would see that clock tick slower and slower as it approaches the boundary. From your perspective, the clock would appear to freeze at the event horizon, its hands stopping, its digital display holding steady, as if time itself had been paused. But here's where the story becomes deeply strange. From the perspective of someone falling with that clock, time continues to pass normally. They don't feel themselves slowing down or freezing. To them, they cross the event horizon in a finite amount of time and continue falling toward the center of the black hole. It's only from the outside observer's viewpoint that time appears to stop. This creates one of the most unsettling paradoxes in physics. The same event, experienced differently by different observers, with no universal agreement on when or even if it actually happens. This is the essence of the black hole information paradox, a puzzle that has kept physicists awake for decades. If information falls into a black hole, what happens to it? According to quantum mechanics, information cannot be destroyed, it must be preserved somewhere. But according to general relativity, anything that crosses the event horizon is lost forever, crushed into the singularity at the black hole's center. These two fundamental theories of physics give contradictory answers, and the resolution remains one of the deepest unsolved problems in science. Stephen Hawking complicated matters further in the 1970s when he discovered that black holes aren't perfectly black. They emit radiation, now called Hawking radiation, due to quantum effects near the event horizon. This radiation causes black holes to slowly evaporate over time, shrinking and eventually disappearing completely. But the radiation appears to carry no information about what fell into the black hole, seemingly violating the quantum principle that information must be conserved. This led to what became known as the Black Hole War, an intellectual battle between physicists over the nature of information and time itself. Some argued that information is indeed destroyed in black holes, requiring us to abandon quantum mechanics as we know it. Others proposed that information is preserved, but encoded in ways we don't yet understand, perhaps holographically on the black hole's surface, or scrambled beyond recognition in the Hawking radiation. Recent developments in theoretical physics have suggested even more radical possibilities. The holographic principle proposes that all the information in a volume of space can be encoded on its boundary, like a hologram. Applied to black holes, this means that everything that falls past the event horizon might actually be stored as information on the black hole's surface, never truly disappearing inside. From this perspective, the three-dimensional reality we perceive might itself be a kind of holographic projection of information encoded on distant boundaries. But perhaps the most mind-bending aspect of black holes is what lies at their center, the singularity. This is a point where density becomes infinite, space-time curvature becomes infinite, and our equations break down completely. At the singularity, time doesn't just slow down or speed up, it ceases to have meaning. The very concept of temporal flow dissolves into mathematical impossibility. Some physicists argue that singularities represent the limits of our current theories, places where general relativity fails and quantum gravity must take over. Others suggest that the singularity might not exist at all, that quantum effects prevent matter from collapsing to a true point, and instead create something else, entirely perhaps a quantum bounce, a wormhole, or a region where space and time become so thoroughly mixed that neither concept applies. These ideas lead us to even stranger possibilities. Some theories suggest that what we perceive as the interior of a black hole might actually be the birth of a new universe, with time flowing in directions we cannot imagine. The Big Bang itself might have been the interior of a black hole in a higher dimensional space, with our entire cosmos expanding not outward from a point, but inward, from an event horizon we can never see. Loop quantum gravity, one approach to unifying quantum mechanics and general relativity, suggests that black holes might not be permanent prisons, but temporary storage facilities. In this view, the intense gravitational field creates a quantum bounce that eventually expels all the trapped matter and energy, but only after an extraordinary amount of time has passed. The black hole becomes a cosmic recycling center, breaking down matter and information before returning them to the universe in new forms. Then there are the truly speculative ideas that push the boundaries of imagination. Some physicists have proposed that black holes might be gateways to other regions of spacetime, cosmic shortcuts that connect distant parts of our universe or even entirely separate universes. The mathematics of general relativity allows for such possibilities, though whether they exist in nature remains unknown. What makes all of this particularly unsettling is that we can never directly observe what happens inside a black hole. The event horizon acts as a one-way information barrier, preventing any signals from the interior from reaching the outside universe. We can study the effects of black holes on their surroundings, observe matter spiraling into them, and detect the gravitational waves they produce when they merge, but their interiors remain forever hidden from direct observation. This cosmic censorship, as physicists call it, might be a fundamental feature of the universe. Perhaps nature has built-in protections that prevent us from witnessing the breakdown of space-time, shielding us from paradoxes and contradictions that would emerge if we could peer directly into a singularity. The event horizon becomes not just a boundary in space, but a boundary of knowledge itself. Recent observations have brought black holes from the realm of theory into stunning reality. The Event Horizon Telescope has captured actual images of the shadows cast by supermassive black holes, showing us the warped spacetime around these cosmic giants. Gravitational wave detectors have recorded the spacetime ripples produced when black holes collide and merge, confirming Einstein's predictions with extraordinary precision. Yet for all our observational triumphs, the deepest questions remain unanswered. What is the true nature of time near a black hole? Is information preserved or destroyed? Do singularities actually exist, or do quantum effects prevent their formation? These questions touch the very foundations of physics and our understanding of reality itself. Perhaps the most profound lesson black holes teach us is humility. They remind us that time, which seems so familiar and intuitive in our everyday experience, becomes alien and paradoxical under extreme conditions. They show us that the universe contains phenomena so strange that they challenge our basic concepts of existence, causality, and knowledge itself. As we continue to study these cosmic enigmas, we're forced to confront the possibility that time as we understand it might be just one facet of a deeper, more complex reality. Black holes might be telling us that our familiar notions of past, present, and future are merely approximations, useful in the gentle gravitational fields of everyday life, but inadequate for understanding the universe's most extreme environments. So the next time you look up at the night sky, remember that scattered among those peaceful points of light are regions where time itself breaks down, where the familiar flow of moments gives way to something far stranger and more wonderful than we yet comprehend. As we continue our journey through the enigma of time, we arrive at one of physics' most captivating frontiers, the quantum realm. Here, in the microscopic world of atoms and particles, time doesn't simply flow like a steady river as Newton once imagined, nor does it merely stretch and bend like Einstein's space-time fabric. Instead, it becomes something far stranger, more elusive, perhaps even questioning its own existence. Welcome to the quantum theatre, where time might just be an actor playing a role rather than the stage itself. In the classical world, the world of our everyday experience, time feels reliable. You set your alarm, catch your train, age gracefully, and watch seasons cycle with predictable rhythm. But zoom down to the quantum scale, down to the realm of electrons and photons, and time begins to behave like a mischievous sprite, popping in and out of equations, sometimes disappearing altogether, leaving physicists scratching their heads and reaching for stronger tea. Let's begin with something beautifully unsettling. Quantum mechanics doesn't actually care much about time as we know it. While Einstein spent years showing us how time and space dance together, bending and warping in cosmic ballet, quantum mechanics treats time more like a bored spectator sitting in the audience, unchanging and absolute. The fundamental equation of quantum mechanics, the Schrödinger equation, describes how quantum systems evolve over time. But here's the curious thing. Time in this equation is what physicists call a parameter, not an operator. In simpler terms, time is just a label, like writing the date in your diary. It tells you when something happens, but it doesn't participate in the quantum weirdness itself. It's the cosmic equivalent of standing at the edge of a dance floor, checking your watch while everyone else tangos with uncertainty. This creates a peculiar split personality in modern physics. On one hand, we have general relativity, where time is dynamic, flexible, and intimately connected to space and matter. Time can slow down near massive objects, speed up in empty space, and even potentially loop back on itself under extreme conditions. It's alive, responsive, part of the very fabric of reality. On the other hand, we have quantum mechanics, where time sits quietly in the background, absolute and unchanging, more like Newton's old clockwork universe than Einstein's elastic cosmos. But the real mystery deepens when physicists try to marry these two theories, attempting to create what's called quantum gravity. This is where things become genuinely mind-bending, because when you try to describe the entire universe using quantum mechanics, including space and time themselves, something remarkable happens. Time vanishes from the equations entirely. This disappearing act occurs in what's known as the Wheeler-DeWitt equation, sometimes called the equation of quantum cosmology. It's an attempt to describe the quantum state of the entire universe, and when you write it down, there's no time variable anywhere to be found. It's as if the universe, when viewed from its most fundamental quantum perspective, exists in a kind of eternal now, a timeless state where past, present, and future lose their meaning entirely. Imagine trying to describe a photograph. You can talk about what's in the picture, where objects are positioned, their colours and shapes, but you can't meaningfully ask when the photograph is happening. The photograph simply is. Some physicists suggest that the universe, at its deepest level, might be like that photograph, a static, timeless configuration where time emerges only when we zoom out, when we look at smaller parts of the system rather than the whole. This leads us to one of the most intriguing ideas in modern physics, the notion that time might be emergent. Just as temperature emerges from the random motion of countless molecules, time might emerge from the complex interactions of more fundamental, timeless quantum processes. Individual molecules don't have temperature, they just move around randomly. But when you have trillions of them together, suddenly temperature becomes a useful concept. Similarly, the fundamental building blocks of reality might not experience time at all, but when they interact in sufficiently complex ways, time emerges as a useful description of change. Think of it like this. Imagine you're watching a movie. The film itself is just a series of still frames, each one frozen and timeless. But when you play them in sequence, suddenly you perceive motion, story, drama. The individual frames don't contain time, but time emerges from their sequence. Some physicists wonder if reality works similarly, with timeless quantum states creating the illusion of temporal flow when viewed from our limited perspective. This idea gets even stranger when we consider quantum entanglement, one of the most mysterious phenomena in all of physics. When two particles become entangled, they remain connected in a way that seems to transcend space and time. Measure one particle, and its entangled partner instantly reacts, no matter how far apart they are. Einstein famously called this spooky action at a distance, and it troubled him deeply because it seemed to violate his carefully constructed space-time. But here's where it gets interesting for our story about time. Some theorists propose that entanglement might be the mechanism through which time itself emerges. As the universe evolves, quantum systems become increasingly entangled with each other, creating a web of correlations that grows more complex over time. The arrow of time, the reason we remember the past but not the future, might simply be the direction in which entanglement increases. Picture the universe as a vast library where every book becomes increasingly interconnected with every other book. At first, each book stands alone, but gradually, references appear between them. Footnotes link to other volumes, and a complex web of connections grows. The direction of increasing connectivity becomes what we experience as the flow of time. In this view, time isn't fundamental, but rather a byproduct of the universe becoming more correlated, more entangled, more interconnected with each passing moment. Then there's the many worlds interpretation of quantum mechanics, which offers perhaps the most radical perspective on time of all. In this view, every quantum measurement, every random event, every coin flip causes the universe to branch into multiple parallel realities. There's a version of reality where the coin lands heads, another where it lands tails, and both are equally real. Time in this interpretation isn't a single river, but an ever-branching delta, splitting into countless streams with every quantum event. If many worlds is correct, then time becomes less about flow and more about selection. We don't move through time so much as we select which branch of reality we experience. Every decision you make, every quantum measurement in every atom of your body creates new timelines. Somewhere out there, in another branch of the quantum multiverse, there's a version of you who chose to have tea instead of coffee this morning, who took a different route to work, who never clicked on this video about time. This raises profound questions about the nature of causality and free will. If every possible outcome occurs in some branch of reality, then what does it mean to make a choice? Are we authors of our destiny, or simply conscious observers riding along one particular thread in an infinite tapestry of possibilities? The many worlds interpretation suggests that time might not be about things happening, but about which version of everything happens we happen to experience. But perhaps the most unsettling quantum perspective on time comes from the measurement problem itself. In quantum mechanics, particles don't have definite properties until they're measured. An electron doesn't have a specific position or momentum until you observe it. Before measurement, it exists in what's called a superposition, a ghostly combination of all possible states. The famous Schrödinger's cat thought experiment illustrates this weirdness. Until you open the box, the cat is supposedly both alive and dead simultaneously. Now, if consciousness or measurement devices are required to collapse quantum superpositions into definite states, what does this mean for time? Some interpretations suggest that time itself might be in superposition until observed or measured. The past might not be fixed, but rather exist in a quantum haze of possibilities until the present moment crystallizes it into actuality. Your memories might not be records of things that definitely happened, but rather the universe's way of maintaining consistency with the particular branch of reality you happen to inhabit. This connects to some of the deepest puzzles in physics. Why does time have an arrow? Why do we remember the past but not the future? Classical physics can't answer these questions because its equations work just as well backward as forward. But quantum mechanics offers a tantalizing possibility. Perhaps the arrow of time emerges from the process of quantum measurement itself. Each measurement, each collapse of a wave function, creates a kind of irreversible event that points time in a particular direction. The quantum view of time also challenges our notion of simultaneity in new ways. Einstein showed us that simultaneity is relative, that events that appear simultaneous to one observer might not be simultaneous to another. But quantum mechanics adds another layer of complexity. If quantum measurements create reality rather than merely revealing it, then the very concept of when something happens becomes deeply problematic. Did the electron have a definite position before you measured it? Did the measurement create the position or merely reveal it? And if measurements create reality, when exactly does the creation happen? These aren't just abstract philosophical questions. They have real implications for how we understand the universe. Take quantum tunneling, for example, where particles can pass through barriers that they classically shouldn't be able to cross. How long does tunneling take? The question seems simple, but it's actually fiendishly difficult to answer because it requires us to define what we mean by time for a quantum process that exists in superposition. Some experiments suggest that quantum tunneling might be instantaneous, taking zero time regardless of the barrier's thickness. Others suggest that the very question is meaningless because time doesn't exist in the usual sense during the tunneling process. The particle doesn't travel through the barrier so much as it ceases to exist on one side and begins to exist on the other, with no meaningful during in between. This connects to broader questions about the role of consciousness in quantum mechanics. Some interpretations suggest that conscious observation plays a special role in collapsing quantum superpositions. If this is true, then consciousness might be intimately connected to time itself. Perhaps time emerges from consciousness, or perhaps consciousness emerges from time. The relationship remains one of the deepest mysteries in physics. As we drift deeper into this quantum meditation on time, we encounter ideas that challenge everything we thought we knew about reality. Time might not be fundamental but emergent. It might not flow but branch. It might not exist independently but require consciousness to become real. The universe might be timeless at its core, with temporal experience arising only from our limited perspective as conscious observers embedded within a larger, static reality. Yet for all these strange quantum possibilities, time remains stubbornly real in our experience. You still age, clocks still tick, cause still precedes effect in your daily life. The quantum strangeness of time reveals itself only at the smallest scales or in the most exotic conditions. It's as if the universe maintains two sets of books, one timeless and quantum for its own internal accounting, and another, temporal and classical, for the benefit of conscious observers like us. This duality might be the key to understanding time's true nature. Perhaps time is neither fully real nor completely illusory, but something in between, a useful approximation that emerges when quantum systems become sufficiently complex and classical. Like the smooth surface of a lake that conceals the chaotic motion of individual water molecules, the flowing river of time might conceal an underlying quantum reality where time doesn't exist in any conventional sense. As you settle into sleep tonight, perhaps you can imagine yourself drifting between these two realities, the classical world where time carries you gently from moment to moment, and the quantum realm where all moments exist simultaneously in timeless superposition. In dreams, after all, time behaves more like quantum mechanics than classical physics. Past and future intermingle, causality breaks down, and impossible things happen with perfect dream logic. And maybe that's the most beautiful insight of all, that in sleep, in dreams, in the quiet spaces between waking thoughts, we briefly return to the timeless quantum state that might be reality's deepest truth. The flow of time, for all its apparent solidity, might be nothing more than the story consciousness tells itself to make sense of a fundamentally timeless universe. We've taken quite a journey through the physical and philosophical landscapes of time, from the ancient rhythms of sundials to the quantum mysteries where time might dissolve altogether. But before we close this chapter, let's pause and consider what all of this means for us, here now, in this moment. Because here's the thing about time, whether it's the rigid tick of atomic clocks or the fluid dance of relativity, whether it emerges from quantum correlations or exists as a fundamental dimension of reality, it remains the stage upon which our lives unfold. Every breath you take, every thought that drifts through your mind, every gentle moment of recognition when you realize you're conscious and aware, all of this happens within time, or perhaps more accurately, as time. Think about it this way. If time is indeed emergent, rising from the complex interactions of countless quantum events, then you are not separate from time's creation. You are part of it. Your neurons firing, your heart beating, your cells dividing and repairing, all of these processes contribute to the forward flow of change that we call time. You're not just living in time, you're helping to weave it into existence with every moment of your being. And if time is fundamental, a basic feature of reality's architecture, then you are synchronized with the universe itself. Your biological rhythms, your circadian cycles, your very experience of now, all of this connects you to the cosmic order. You're not an outsider looking in at the universe. You're a participant in its temporal symphony. Consider the light from distant stars that reaches your eyes tonight. Those photons have been traveling for years, decades, centuries, carrying information from when those stars were younger, perhaps when Earth was a different place entirely. Yet they arrive precisely now, in this moment, to meet your gaze. There's something profound in that connection, a thread of causality linking you to the deep history of the cosmos. Or think about your memories, those strange treasures of the mind that seem to bring the past into the present. When you remember a childhood summer or a conversation from last week, you're not just recalling information, you're experiencing time's peculiar ability to fold back on itself. The past lives in your present moment, carried forward by the neural patterns in your brain, creating a kind of temporal layering that makes you more than just a point moving through time. Even your anticipation of the future, your hopes and plans, and quiet wonderings about what's to come. These too are part of time's texture. The future doesn't exist yet, at least not in any way we can access, but your ability to imagine it, to prepare for it, to worry about it, or look forward to it. This makes you a bridge between what was and what might be. This is why the question of time's existence feels so personal. It's not just an abstract puzzle for physicists to solve in their laboratories. It's about the nature of your own experience, the reality of your own consciousness, the meaning of your own story. Whether time is real or illusory, fundamental or emergent, it shapes every aspect of what it means to be human. And perhaps that's enough. Perhaps the answer to whether time exists isn't found in equations or experiments, but in the simple fact that you're here, aware, experiencing this moment, connected to the vast web of causality that links every atom in your body to the birth of stars, every thought in your mind to the quantum dance of electrons, every beat of your heart to the rhythm of the universe itself. The ancient Greeks had a word kairos which meant not just time but the right time, the opportune moment, the perfect instant when everything aligns. Maybe that's what this moment is for you right now, as you consider these ideas. A moment of kairos when the mystery of time becomes not a problem to solve, but a wonder to experience. So as you drift towards sleep tonight, or continue with your day, or simply sit quietly with these thoughts, remember that you are time's child and time's creator, time's observer and time's participant. You are woven into the very fabric of temporal reality, whatever that reality might be. And in that weaving, in that connection, in that dance between consciousness and cosmos, perhaps we find not the answer to time's mystery, but something even more valuable, a sense of belonging to the universe's deepest patterns. Time may be the most fundamental mystery we face, but it's also the most intimate. It's the rhythm of your breathing, the flow of your thoughts, the gentle passage from one moment to the next. And now, dear listener, as our gentle exploration of time draws toward its close, we find ourselves in perhaps the most intimate space of all, the present moment. After wandering through the mathematics of relativity and the mysteries of quantum mechanics, after contemplating black holes and the possibility of time travel, we arrive at a simple truth. Time, whatever its ultimate nature, is deeply personal. You see, while physicists debate whether time is fundamental or emergent, whether it flows or simply exists, there's something undeniably real about your experience of it right now. The way it stretches during moments of boredom, compresses during joy, and seems to vanish entirely when you're absorbed in something meaningful. Your biological clock ticking away with its ancient rhythms, your memories creating the illusion of a flowing past, your anticipation painting pictures of possible futures. And perhaps that's where the true magic lies. Not in the equations or the exotic theories, but in the way time shapes consciousness itself. Without time, there would be no stories, no memories, no hopes. There would be no music, because music exists in the unfolding of moments. There would be no love, because love grows and deepens through shared time. There would be no meaning, because meaning emerges from the sequence of events that form a life. Consider this. Every thought you're having right now, every gentle breath, every quiet heartbeat is part of time's grand symphony. The photons carrying these words to your eyes have travelled at the speed of light. The neurons in your brain are firing in precise temporal sequences, and somewhere in the universe, stars are being born and dying, their light carrying stories across the cosmos at that same unwavering pace we've come to know so well. Time may be the universe's most elaborate illusion, but it's also its most generous gift. It gives us the space between cause and effect, the pause between question and answer, the gentle rhythm that allows consciousness to emerge from complexity. Without time, everything would happen at once, which is to say, nothing would happen at all. So as you drift towards sleep tonight, perhaps you can appreciate the curious position you occupy. You're a temporary arrangement of atoms, borrowing energy from the universe for a brief span, experiencing the flow of time through the lens of consciousness. You're both ancient, made of elements forged in the hearts of stars billions of years ago, and utterly modern, a unique pattern that has never existed before and never will again. The light reaching your eyes from distant stars carries messages from the deep past. The warmth you feel carries energy that began its journey in the sun's core tens of thousands of years ago. And yet here you are, in this moment, receiving these gifts from time itself. Time may not exist in the way we think it does. It may be an emergent property of complexity, a useful fiction, created by consciousness, a psychological construct born from memory and anticipation. But even if it's not fundamental to the universe, it's fundamental to you. It's the canvas on which your life is painted, the stage on which your story unfolds, the gentle current that carries you from one moment to the next. And in the end, isn't that enough? Whether time is real or imagined, absolute or relative, flowing or static, it remains the medium through which you experience wonder, love, curiosity, and peace. It's what allows you to listen to these words, to contemplate their meaning, and to drift gently into dreams where time becomes fluid once again. So tonight, as you surrender to sleep, remember that you are time's most remarkable creation, a conscious being capable of contemplating its own existence, of questioning the nature of reality, of finding beauty in the mystery of it all. You are time made aware of itself, the universe's way of experiencing its own strange and wonderful nature. Sleep well, fellow traveller in time. Tomorrow's moments are waiting patiently for you, ready to unfold their own gentle mysteries. And who knows, we find ourselves at a peculiar intersection of inquiry, where the nature of measurement itself becomes the subject under scrutiny. Having journeyed through the quantum mechanical foundations of reality, where particles exist in superposition and entanglement defies our classical intuitions, we now arrive at a curious paradox. Time, this seemingly fundamental aspect of our existence, begins to reveal itself as something far more elusive than the steady tick of a clock might suggest. Consider the profound implications of what we've discovered. In the quantum realm, The very act of measurement collapses wave functions and determines outcomes. Yet here we are, attempting to measure time itself, to pin down its essence through equations and observations. It's rather like trying to catch your own shadow, always one step ahead, always slipping through your fingers just as you think you've grasped it. The measurement problem in quantum mechanics tells us that reality itself seems to depend on observation. Before measurement, particles exist in all possible states simultaneously. Only when we observe do they choose, as it were, a definite position or momentum. But what happens when we turn this lens toward time? Can we measure time without fundamentally altering our relationship to it? Perhaps the very tools we use to study time clocks, rulers, even our own consciousness, are themselves embedded within the temporal flow we're trying to understand. This creates a rather beautiful recursion. We are temporal beings, existing within time, using time-dependent processes in our brains and instruments to study the nature of time itself. It's like being inside a river while trying to map its course. Every measurement we make, every thought we think about time's passage, occurs within the very framework we're attempting to examine from the outside. But here's where it gets truly fascinating. Just as quantum mechanics suggests that reality might be fundamentally relational rather than absolute, perhaps time too is not a thing we measure, but a relationship we participate in. When you check your watch or feel the rhythm of your heartbeat, you're not extracting some objective truth about time's passage. You're engaging in a dance, a correspondence between your consciousness, your measuring devices, and the deeper rhythms of the universe. Think about it this way. A clock doesn't contain time any more than a thermometer contains temperature. These instruments reveal relationships, patterns of change, frequencies of oscillation, the steady beat of atomic transitions. They're not capturing time itself, but rather the comparative rates at which different processes unfold. Your heartbeat against the swing of a pendulum, the decay of radioactive atoms against the rotation of the Earth. This relational view of time suggests something rather profound about measurement itself. Perhaps we never truly measure time in isolation. Instead, we're always measuring the relationship between different temporal processes, comparing one rhythm to another, one rate of change to a different rate of change. The second, that fundamental unit we've anchored to the oscillations of cesium atoms, is not a piece of time we've captured, but a standardized relationship we've agreed upon. And this brings us to consciousness, that mysterious observer at the heart of every measurement. Your subjective experience of time's passage, the way moments seem to stretch during boredom or compress during joy, might not be a distortion of some objective temporal truth. It might be the most direct access we have to time's fundamental nature. After all, consciousness itself is a temporal process, a flow of experiences, memories forming and dissolving, attention shifting from moment to moment. When you experience that strange phenomenon, where time seems to slow during a crisis, when details become hyper-vivid and seconds stretch like hours, perhaps your consciousness is revealing something true about the flexible, relational nature of time itself. Not an illusion, but an insight. Not a malfunction of your internal clock, but a glimpse of how time really behaves when observed closely enough. The measuring instruments we've built, atomic clocks, GPS satellites, gravitational wave detectors, are extensions of human consciousness, ways of amplifying and standardizing our temporal perception. But they don't eliminate the observer from the equation. They simply distribute the act of observation across networks of synchronized measurements, creating a collective, technological consciousness that we trust more than our individual subjective experience. Yet even these magnificent instruments encounter limits. At the smallest scales, the Heisenberg uncertainty principle suggests that the very act of measuring position and momentum introduces unavoidable imprecision. Similarly, might there be fundamental limits to how precisely we can measure time? Not due to technological limitations, but due to the nature of temporal reality itself? Consider the Planck time, approximately 10 to the minus 43 seconds, derived from fundamental constants of nature. Below this scale, our current theories suggest that the smooth fabric of space-time breaks down into a quantum foam, where our ordinary concepts of before and after lose meaning. Here perhaps we reach the edge of measurability, not because our instruments are inadequate, but because measurement itself becomes undefined. This returns us to that haunting question from quantum mechanics. If consciousness plays a fundamental role in collapsing quantum states, might it also play a role in the emergence of time? Some interpretations suggest that the flow of time, the arrow pointing from past to future, emerges from the accumulation of irreversible quantum measurements. Each observation, each moment of conscious awareness, might be another stitch in the fabric of temporal experience. So when we ask whether time exists, we might be asking the wrong question. Instead, we might ask, what is the relationship between time, measurement, and consciousness? How do these three interweave to create the temporal experience we call reality? And perhaps most intriguingly, what does it mean to be a conscious observer embedded within the very phenomenon we're trying to understand? The answer, like time itself, remains beautifully elusive. We are neither outside time looking in, nor simply carried along by its current. We are participants in an ongoing creative process where measurement, consciousness, and temporal flow dance together in patterns we're only beginning to glimpse. Throughout this vast cosmic dance we've witnessed together, we've seen how time might not be the flowing river of common experience, but rather something far more profound, far more mysterious. From the earliest philosophers pondering duration, to Einstein's revolutionary insights about space-time, from quantum mechanics questioning time's very existence, to the biological rhythms pulsing within us, we've explored every corner of this deepest mystery. And now, as we draw these threads together, we arrive at perhaps the most fascinating question of all. If time isn't what we think it is, then what does that mean for us? Living our lives moment by moment, memory by memory, heartbeat by heartbeat. The answer, it seems, lies not in choosing between the scientific and the personal, but in embracing both. Because while physics may reveal time as emergent, relative, or even illusory, our experience of it remains beautifully, stubbornly, profoundly real. We still wake to morning light, still feel the gentle passage of seasons, still carry memories like treasures and hopes like gentle flames. Consider this: every tradition of human wisdom has grappled with time's mysteries. Ancient mystics spoke of eternal moments, poets wrote of time's swift passage, and philosophers debated whether the present moment truly exists. They weren't wrong to wonder. They were touching something deep about the nature of reality itself, something that modern physics is only now beginning to illuminate. Time, in all its scientific strangeness, hasn't lost its human meaning. If anything, understanding its deeper nature makes our experience of it more precious, not less. The fact that simultaneity is relative doesn't diminish the joy of sharing a sunset with someone you love. The knowledge that time dilates at high speeds doesn't make your morning coffee taste any less perfect. The possibility that time emerges from quantum processes doesn't make childhood memories any less sweet. What it does do is remind us that we are participants in something extraordinary. Every moment you experience, every memory you form, every plan you make is part of the universe's own unfolding story. You're not just observing time, you're helping to create it through the very act of being conscious, of remembering, of existing as a complex pattern in the cosmic web. The block universe theory suggests that all moments exist simultaneously, that your past and future are equally real. But that doesn't mean your choices don't matter. It means they're woven into the eternal fabric of everything that is. The arrow of time may emerge from increasing entropy, but that doesn't make your story any less meaningful. It makes you part of the universe's grand narrative of change and growth. And if time truly is emergent, arising from the complex dance of quantum interactions, then consciousness itself, Your consciousness plays a role in bringing time into being. You're not just living in time, you're helping to create it through the simple, miraculous act of being aware. Perhaps this is why time feels so personal, so intimate. It's not just that we experience time subjectively, it's that time might not fully exist without experience, without consciousness, without beings like us to witness and remember and anticipate. We are time's storytellers, its memory keepers, its meaning makers. The universe has spent nearly 14 billion years preparing for this moment, for consciousness to emerge and begin asking these questions. Atoms forged in stellar cores, planets forming in cosmic dust, life arising from chemical possibility, and finally awareness, memory, the experience of duration and change. Time's arrow has been pointing toward this, minds capable of contemplating time itself. So as you drift off tonight, as your consciousness settles into the rhythm of rest, remember that you carry within you one of the universe's deepest mysteries. Your sense of time, your memories, your dreams, they're not separate from the cosmic story. They're part of it. The same processes that create the arrow of time, that give structure to space-time, that allow cause to precede effect, they're all present in the gentle rhythm of your breathing, the quiet flow of your thoughts. Time may be stranger than we imagined, more flexible, more mysterious, perhaps even more fundamental to consciousness than to physics. But it's also more beautiful for being strange, more precious for being enigmatic, more meaningful for being part of the deepest questions we can ask about reality. Whether time flows like a river or stands like a mountain, whether it emerges from quantum foam or structures, the cosmos from the beginning, one thing remains constant. We are here, now, aware and wondering. We are the universe's way of experiencing time, of questioning time, of finding meaning in time's passage. And in this quiet moment, as sleep approaches and the day's concerns fade, perhaps that's enough. Time exists in our experience of it, in our capacity to remember yesterday and dream of tomorrow while resting peacefully in the eternal now. We are time's witnesses, its participants, its grateful children, but remember, the universe has been waiting billions of years for this moment of rest, this quiet gratitude, this simple human wonder at the passage of days. As we reach the final chapter of our journey through time, we find ourselves standing at the edge of perhaps the most profound mystery we've encountered. Having wandered through the mathematics of relativity, the strangeness of quantum mechanics, and the gentle rhythms of biological clocks, we arrive at a place where science meets something deeper, something that touches the very core of what it means to be human. Because while we can measure time with atomic precision and bend it with gravity, there remains one aspect of time that no equation can fully capture: how it feels to be alive within it. Let's settle into this final contemplation gently, like sinking into a favourite chair at the end of a long day. Throughout our exploration, we've discovered that time is both more flexible and more fundamental than we ever imagined. We've seen it stretch near black holes, emerge from quantum entanglement, and tick differently in the cells of our bodies. We've traced humanity's long journey from sundials to atomic clocks, watched dreams unfold in REM sleep's temporal theatre, and marvelled at light racing across the cosmos at its unchanging pace. Each discovery has peeled back another layer of time's mystery, revealing complexity beneath simplicity, poetry beneath physics. But perhaps the most remarkable thing about time isn't what science has taught us about its nature, but what it teaches us about ourselves. Because for all our sophisticated theories and precise measurements, time remains deeply, intimately personal. Your experience of this moment, right now, as these words flow through your consciousness, is something no clock can measure and no equation can describe. It's the difference between knowing that a second lasts 19 billion heartbeats of a cesium atom and feeling that second stretch like honey when you're waiting for news you desperately want to hear. This brings us to one of time's most beautiful paradoxes. The more we understand it scientifically, the more mysterious it becomes experientially. We know that simultaneity is relative, that there's no universal now, that the present moment is more of a fuzzy boundary than a sharp line. Yet here you are, undeniably experiencing this now, this moment of consciousness that feels absolutely real and immediate. You're not experiencing the block universe where all moments exist equally. You're not feeling the quantum superposition of temporal states. You're simply here, aware, present, riding the wave of becoming that carries you from one moment to the next. And maybe that's exactly as it should be, because while time might be an emergent property of quantum interactions or a coordinate in the geometry of space-time, it's also the medium in which love grows, in which children learn to walk, in which grief softens into memory. It's the canvas on which we paint our stories, the rhythm that gives meaning to music, the gentle current that carries us from birth to death, and every precious moment in between. Time might not exist in the way we think it does, but it exists in the way we live it, and perhaps that's the most important truth of all. Consider how time weaves through the fabric of human meaning. We mark our days with rituals and celebrations, creating temporal landmarks that give shape to existence. Birthdays and anniversaries, first steps and last words, the moment you fell in love, and the day you said goodbye. These aren't just points on a timeline, they're the architecture of identity, the scaffolding of story. We are, in so many ways, temporal beings, creatures who exist not just in space but in narrative, in the unfolding relationship between memory and anticipation, between what was and what might be. Even our language reveals this deep entanglement with time. We speak of spending time, saving time, running out of time, as if it were a precious resource we could hoard or squander. We talk about the past as behind us and the future as ahead, creating spatial metaphors for temporal experience. Some cultures point backward to indicate the future, reasoning that the past is what we can see clearly, while the future remains invisible. These aren't just linguistic quirks, they're windows into how consciousness constructs itself through temporal metaphor. And then there's the curious relationship between time and creativity. So many of our greatest artists, writers, and musicians have wrestled with time's mysteries, trying to capture its essence in their work. They speak of inspiration striking like lightning, of being in the flow where time seems to disappear, of the eternal moment that contains all moments. Perhaps creativity is humanity's way of playing with time, of bending it to our will in the one realm where we truly can, the realm of imagination and art. The scientists we've met on this journey were themselves artists of a sort, painters of possibility who used mathematics and observation to sketch the contours of reality. Einstein didn't just discover relativity, he imagined it, riding alongside beams of light in thought experiments that required as much creativity as calculation. The researchers studying dreams don't just measure brain waves, they peer into the theatre of the sleeping mind, trying to understand how consciousness constructs experience from the raw materials of memory and sensation. Every scientific discovery about time has been, at its heart, an act of imagination made manifest. As we near the end of our exploration, it's worth reflecting on how our understanding of time has changed throughout human history. Our ancestors lived by the rhythms of sun and season, marking time by the natural cycles that surrounded them. The invention of mechanical clocks brought precision, but also disconnection, allowing us to slice time into ever smaller portions while perhaps losing touch with its organic flow. Now in our digital age, we carry atomic clock precision in our pockets, while often feeling more rushed and time-starved than ever before. Perhaps there's wisdom in remembering that time, for all its scientific complexity, is ultimately about presence. The mystics and meditators have always known what physics is slowly discovering. that the present moment is where life actually happens, not in the past, which exists only as memory, or in the future, which exists only as possibility, but right here, right now, in the eternal unfolding that we call experience. When we're fully present, time doesn't disappear exactly, but it transforms from a river carrying us along to an ocean in which we float, vast and deep and mysteriously still. This doesn't mean we should ignore what science has taught us about time's true nature. Understanding relativity and quantum mechanics, biological rhythms, and psychological perception doesn't diminish the mystery so much as deepen it. We can appreciate both the mathematical elegance of Einstein's equations and the simple wonder of watching a sunset. We can marvel at the precision of atomic clocks while also treasuring the way time seems to slow when we're fully absorbed in something we love. Science and experience aren't in competition, they're different languages describing the same magnificent mystery. So as we prepare to close this gentle journey through time's landscapes, let's hold all of these truths together. Time might be relative, but your experience of it is absolutely real. It might emerge from quantum processes, but it emerges as something beautiful and meaningful. It might not exist in the fundamental structure of reality, but it creates the structure of human reality. It might be an illusion, but if so, it's the most important illusion we have, the one that makes story possible, that turns existence into experience, that transforms the mere fact of being into the rich complexity of becoming. And perhaps that's the final secret about time. It's not just something we exist within, but something we create through the very act of living. Every moment of consciousness, every beat of attention, every thread of memory weaving into anticipation contributes to time's ongoing creation. We don't just experience time, we participate in its unfolding. We are both characters in time's story and co-authors of its telling. In the end, time remains what it has always been, the medium of change, the dimension of story, the rhythm of becoming. Whether it's fundamental or emergent, real or illusory, matters less than how we choose to inhabit it. We can rush through our days counting seconds, or we can settle into moments and let them expand. We can fear time's passage, or we can dance with it. We can see it as an enemy stealing our youth, or as a friend offering us the gift of experience, growth, and the precious opportunity to love and be loved within the brief span of our existence. So tonight, as you prepare to sleep and dream, as your biological clocks slow and your consciousness prepares to dive into the timeless realm of sleep, remember this: you are a temporal being in a universe that may or may not be temporal, creating meaning and beauty and love within the mystery of moments that may or may not truly exist. And somehow, miraculously, that's enough. That's everything. Time in all its scientific complexity and experiential simplicity, in all its cosmic grandeur and intimate immediacy, continues its ancient dance. And you, dear traveller through moments, are part of that dance, adding your own steps to the eternal choreography of becoming. We've journeyed far together, wandering through the deepest questions about time's nature, from its apparent flow in our daily lives to its strange behaviour near black holes, from quantum uncertainties to the biological rhythms that pulse within us. We've seen time stretch and contract, emerge and perhaps dissolve, always dancing just beyond our complete understanding. Now, as we approach the end of our exploration, it's worth pausing to consider what all of this means for us, here and now, in this particular moment of whatever time actually is. Because whether time is fundamental or emergent, real or illusory, absolute or relative, one thing remains beautifully, stubbornly true. We live within it, we experience it, and it shapes every story we tell. Think about the paradox we've uncovered. On one hand, physics suggests that time might not exist at all in the deepest sense. The Wheeler-DeWitt equation describes a timeless universe. Block eternalism tells us all moments exist simultaneously. Quantum mechanics hints that time emerges from something more fundamental, like temperature arising from the motion of countless particles. These aren't just abstract ideas, they're serious scientific proposals about the nature of reality itself. Yet here you are, listening to these words in sequence, following a story that unfolds from beginning to middle to end. Your heart beats in rhythm, your thoughts flow in streams, your memories stack like layers of sediment from past to present. The contradiction is profound. The universe might be timeless, but consciousness is thoroughly temporal. We are time-bound creatures trying to understand a potentially timeless cosmos. Perhaps that's precisely what makes us human. We exist at the intersection of the eternal and the momentary, the cosmic and the personal. We're made of atoms forged in ancient stars, carrying forward billions of years of evolution. Yet we experience each moment as fresh, immediate, unrepeatable. Time, whether real or constructed, gives us the gift of narrative. It lets us remember where we've been, imagine where we're going, and make meaning from the space between. Consider how time weaves through everything we've explored. Your circadian rhythms evolved over millions of years to match Earth's rotation, connecting you to the planet's ancient dance with the sun. The light reaching your eyes left distant stars years, centuries, or millennia ago, carrying stories written in wavelengths across the vast darkness. The quantum processes in your brain that generate consciousness somehow give rise to your sense of temporal flow, your feeling that now is special, that this moment matters. Even our attempts to measure time reveal its mystery. We've built atomic clocks that tick with extraordinary precision, devices that can detect the tiniest changes in time's passage. Yet these clocks measure something we still don't fully understand. They count the oscillations of cesium atoms, the vibrations of quartz crystals, the decay of radioactive particles, all marking the passage of something that might not even exist independently of the systems doing the measuring. Music isn't a thing you can hold or point to. It's a pattern, a relationship, an experience that emerges when sounds are arranged in certain ways across time. Similarly, time might not be a thing, but a pattern, a relationship, an experience that emerges when events are arranged in certain ways across space. If that's true, then time exists in the same way that stories exist, the same way that love exists, the same way that consciousness exists, not as objects in the world, but as structures of meaning, as ways that complex systems like brains or societies or universes organize themselves. Time would be real not because it's written into the fundamental laws of physics, but because it's written into the fundamental nature of experience itself. This perspective offers a kind of comfort. Whether time is absolute or relative, fundamental or emergent, it remains the medium through which we live our lives. It's the canvas on which we paint our experiences, the rhythm to which we move, the river that carries us from birth to death, and everything in between. Time gives us seasons and cycles, growth and change, the ability to learn from the past and hope for the future. And perhaps most importantly, time gives us each other. Every relationship, every conversation, every moment of connection happens within time's embrace. The words you're hearing now exist only because time allows for sequence, for cause and effect, for the delicate dance between speaking and listening, writing and reading, sharing and receiving. So as we reach the end of our journey through time's mysteries, we find ourselves back where we started, in time, with time, as expressions of time itself. We are not separate from time, observing it from the outside. We are time's way of experiencing itself, consciousness emerging from complexity, stories arising from the interplay of matter and energy across the cosmic centuries. The next moment is always arriving, carrying with it new possibilities, new questions, new wonders to explore. Whether that moment exists already in some eternal block universe, or emerges fresh from the quantum foam, or unfolds according to laws we haven't yet discovered, it will be yours to experience. And in that experience, in that very personal encounter with the mystery of temporal existence, time becomes real in the only way that ultimately matters. Time flows on, or perhaps we flow through it, or perhaps we are it, dreaming itself into being, one moment at a time, one story at a time, one gentle breath at a time. The universe may be timeless, but we are its temporal children, and in our brief, bright existence, we make time real through the simple, profound act of being alive within it. Sleep well, fellow traveller through time. As we reach the final moments of our gentle journey through time, let's pause and reflect on the extraordinary voyage we've shared together. We began with the simple tick of a clock, the shadow of a sundial, the patient observations of ancient astronomers marking seasons and cycles. We've wandered through the revolutionary insights of Newton, who gave time its mathematical backbone, and Einstein, who bent that backbone into something far more fluid and mysterious than anyone had imagined. We've seen time stretch and compress near the speed of light, watched it slow in the grip of gravity, and discovered that simultaneity itself depends on where you stand and how fast you're moving. We've peered into the quantum realm, where time becomes fuzzy, emergent, perhaps even illusory. We've felt the biological rhythms pulsing through our cells, the circadian dance that connects us to the ancient rotation of Earth, and we've explored the psychological time that stretches minutes into hours when we're bored and compresses years into moments when we're absorbed. Through it all, we've confronted the deepest question of all: does time truly exist? The answer, as we've discovered, is beautifully complex. Time may not be the flowing river we imagine, the absolute backdrop that Newton envisioned, or even the fundamental dimension that Einstein described. It might be emergent, constructed, a story our brains tell themselves to make sense of change and causality. But whether time is real or constructed, fundamental or emergent, absolute or relative, it remains the medium through which consciousness unfolds. Every memory you've formed, every decision you've made, every relationship you've built has been shaped by your experience of time. The child you were exists in your past, the adult you've become stands in your present, and the person you might yet be waits somewhere in your future. Time gives structure to identity, meaning to growth, and poignancy to loss. It makes stories possible, love precious, and moments worth savouring. Perhaps that's the most profound insight of all. In a universe that might be fundamentally timeless, where past, present, and future could all exist simultaneously in some grand block universe, we conscious beings create our own experience of temporal flow. We are the ones who remember, who anticipate, who live in the eternal now while carrying the past and reaching toward the future. We are time's witnesses, its interpreters, its meaning makers. And in this sense, the question of whether time exists becomes less important than the fact that we exist within it, or it within us. Whether time is the canvas on which reality is painted or the paint itself, whether it's the stage on which the cosmic drama unfolds or part of the performance, it remains inseparable from everything we are and everything we experience. As you drift towards sleep tonight, wherever you are, whenever you are, remember that you are part of this vast temporal tapestry. The atoms in your body were forged in stars billions of years ago. The thoughts in your mind emerge from patterns shaped by evolution across deep time, and the dreams you're about to dream will unfold in that mysterious realm where past and future, memory and imagination blend into something uniquely, beautifully, unmistakably now. Time may be the universe's greatest mystery, but it's also its greatest gift. It gives us duration to experience wonder, sequence to create meaning, and the precious present moment in which all conscious life unfolds. Whether time flows or we flow through it, Whether it's real or imagined, absolute or relative, it remains the quiet companion that makes everything else possible. So rest easy, fellow traveller through time. Tomorrow will bring new moments to experience, new changes to witness, new stories to live. And whether you're drifting through minutes or years, through dreams or waking hours, through the swift passage of youth or the measured pace of age, you're participating in one of the most extraordinary phenomena in all of existence, the unfolding of conscious experience through the dimension we call time. The clocks will keep ticking, the earth will keep turning, the universe will keep expanding, and somewhere in the midst of it all, you'll keep being you, moment by moment, breath by breath, heartbeat by heartbeat. And in that simple fact lies perhaps the deepest truth of all, that whether time is real or not, whether it exists independently or emerges from something else, it is the medium in which we love, learn, grow, and find meaning. Sweet dreams, dear listener. May your sleep be peaceful, your dreams be gentle, and your journey through time, whatever it may bring, be filled with wonder, wisdom, and the quiet joy of being alive in this moment, in this universe, in this mysterious, beautiful, ever unfolding now.